Something changed when 3i Atlas vanished behind the sun. In the silence, instruments went dark, magnetic fields pulsed in rhythm, and the sun itself seemed to answer an unseen signal. When the object reappeared, its chemistry had shifted, its tail moved in patterns that mirrored solar flares, and its light carried a rhythm too precise to be random. Scientists now call it solar synchrony, a mysterious resonance between a star and something that should have been lifeless. But what if it was not reacting at all? What if it was responding? Tonight, we follow the trail of data that was never meant to be found. From the magnetic pulse that echoed through the planets to the hidden pattern buried in light itself, this investigation reveals a universe that might not be silent after all, but speaking in a language written in rhythm, geometry, and fire. When 3i Atlas slipped behind the sun, the world entered a strange silence. For weeks, astronomers had watched it with growing tension, waiting for the moment when it would vanish from every telescope on Earth. The disappearance was expected, but what happened next was not. Just as the object crossed the solar limb and vanished from view, the sun erupted. Flares burst in rhythmic succession, each one timed as though it had been triggered by the very passage of 3i Atlas itself. Solar flares are not unusual, but their timing often carries no pattern. Yet here, the eruptions seemed to follow a pulse. Each flare was separated by nearly identical intervals. The coronal loops twisted like synchronized dancers. Even the magnetosphere around Earth responded in tune. Scientists watching the data feeds began to notice something unsettling. The solar activity seemed aware of something. The rhythm was too precise to dismiss as coincidence. Some at the European Space Agency described it as a cosmic heartbeat. Others tried to dismiss the connection as random alignment, but the pattern persisted in multiple wavelengths. Radio bursts, ultraviolet spikes, and X-ray pulses all mirrored the object's invisible trajectory behind the sun. It was as though the sun and 3i Atlas were engaged in a silent conversation, one that no instrument on Earth could fully interpret. Then came the blackout. For nearly 2 weeks, data from several observatories became corrupted or incomplete. The solar orbiter transmitted garbled telemetry. NASA's test satellite missed entire intervals. Even the usually reliable stereo spacecraft recorded static during moments it should have captured perfect solar frames. Engineers called it coincidence. But there is a limit to how many coincidences the universe can provide. When 3i Atlas finally emerged again, its spectral signature had changed. Before the blackout, it displayed a consistent chemical fingerprint dominated by carbon dioxide and water vapor. Afterward, the ratio shifted dramatically. Trace metals appeared in the readings, elements that should have burned away long before reaching the sun. The object seemed to have adapted or transformed during its hidden passage. The most troubling discovery came from a comparison of coronal mass ejections during the blackout. 3 separate ejections originated from the same region of the sun, each separated by an almost identical time span. The timing matched the predicted perihelion speed of 3i Atlas to the second. Nothing in known solar physics explains that kind of precision. The probability of such synchronization occurring naturally is so small it borders on impossible. Some researchers suggested that the sun's magnetic field could have influenced the object, creating an illusion of timing, but deeper analysis revealed the opposite. The object's motion appeared to slightly precede the flare activity, as though the sun were reacting to it, not controlling it. If that is true, it means 3i Atlas is not merely a passive traveler through our solar system. It may be interacting with the sun in ways we do not yet understand. The blackout created a hole in the timeline of observation. Every missing image, every corrupted frame, every moment of silence now feels like a gap in a story the universe was trying to tell. The absence of data became the most telling evidence of all. In scientific research, absence is rarely proof of anything. Yet in this case, it forms a pattern of its own. Instruments that never fail stopped recording exactly when the object passed behind the Sun. Even more puzzling were the readings from Earth-based magnetometers. During the blackout period, subtle oscillations appeared across multiple stations, synchronized with solar activity, yet out of phase with the expected solar wind delay. It was as if the planet itself felt the echo of something vast moving behind the Sun. Some researchers at NASA quietly admitted the possibility of a resonant coupling event, a kind of energy exchange that occurs when two magnetic systems momentarily align. But they could not explain why it happened now, or why it had not happened with any other interstellar object. Publicly, the agencies maintained silence. Press releases remained vague, focusing on other celestial events, while avoiding mention of 3I Atlas. Amateur astronomers noticed the omission immediately. Online forums filled with speculation about what the agencies were not saying. A few even claimed to have captured indirect evidence of the object's influence through radio interference patterns. Though unverified, these recordings showed oscillations that seemed to mirror the same mysterious rhythm seen in the flares. The blackout became more than an observational gap. It turned into a moment of collective doubt. The idea that something beyond our understanding could be interacting with the Sun unsettled many in the scientific community. Some warned against sensationalism, yet behind closed doors, researchers began running new simulations of magnetic coupling scenarios, what they found deep in the mystery. When they modeled a conductive object entering the Sun's magnetic field at the precise angle of 3I Atlas, the simulated field responded in pulses nearly identical to the observed flare pattern. That result does not prove intelligence, but it raises difficult questions. How could a natural body maintain such timing? Why would the Sun respond so predictably? Could it be that interstellar objects carry properties capable of tuning into solar harmonics, almost like a resonance key? The Sun has always been treated as a stable constant, but perhaps it is part of a larger network. Perhaps certain objects, when they enter its influence, trigger reactions that reveal an underlying structure in the solar system we have never detected before. When 3I Atlas came out from behind the Sun, its new appearance was subtle yet unmistakable. Its tail no longer dispersed evenly, it pulsed faintly in visible and infrared spectra. That pulse matched the solar flare intervals recorded during its absence. The object seemed to carry the rhythm with it, as if echoing the memory of the interaction it had just experienced. Observers at the Keck Observatory noted an unusual polarization effect in its reflected light. It suggested that the material on its surface might have been rearranged at the molecular level, as if exposed to an intense and organized field. Such changes do not occur naturally from simple radiation. They imply that something within that blackout period modified its structure in a way that aligned with the Sun's energy flow. The deeper scientists looked, the more the timing defied explanation. It was no longer a random comet passing through. It behaved as though it was synchronized to a pattern larger than itself. The data led some to a disturbing thought. If 3I Atlas was capable of interacting with the Sun in such a way, what else might it be capable of when approaching another star? The vanishing moment marked not just a pause in observation, but perhaps the first sign that interstellar visitors are not merely travelers. They may be participants in a cosmic system of cause and response that we have only begun to notice. Something changed during that hidden passage. Whether it was the object, the Sun, or both remains unknown. But one truth stands clear. The universe was not still during the silence. It was listening. Every pattern in nature tells a story, and for centuries, scientists have believed that the Sun's rhythm is guided only by the laws of physics. But the deeper researchers looked into the data surrounding 3I Atlas, the less natural those rhythms began to appear. It was as if a cosmic drummer had joined the orchestra of the solar system, setting a new beat that only a few could hear. When the Sun released its flares during the blackout, their spacing followed a strange cadence. The intervals between each eruption mirrored the projected orbital motion of 3I Atlas. Each flare pulsed almost exactly when the object would have been at a particular point in its trajectory. It was so precise that analysts at the Solar Dynamics Laboratory had to double-check their timestamps, thinking there might be an internal software glitch. But the data was real. It appeared that the Sun and 3I Atlas were keeping time together. This should not be possible. The Sun operates on plasma cycles shaped by magnetic turbulence, not external timing mechanisms. Even gravitational influences from massive planets like Jupiter can only shift solar behavior by fractions, not entire synchronized sequences. Yet here was a chain of events that aligned across multiple instruments. It was not a vague alignment either. The match was nearly perfect to within minutes. At first, astrophysicists dismissed it as pattern seeking, a human tendency to find order where none exists. But the evidence grew too consistent to ignore. The rhythm repeated in coronal mass ejections and ultraviolet bursts. Each time 3I Atlas adjusted its speed or path, the Sun answered. Some began to call this the solar mirror effect, though no one could define what was being mirrored. One researcher compared the phenomenon to musical resonance. When two instruments share a harmonic frequency, even a distant vibration can cause the other to tremble. Could something similar be happening on a cosmic scale? Perhaps 3I Atlas carried a magnetic signature that resonated with the Sun's field, amplifying certain frequencies that caused energy release. If so, that would mean our solar environment is far more sensitive to external triggers than previously imagined. The rhythm continued even after the blackout ended. Solar wind readings from Earth's magnetosphere picked up pulsing variations that matched the earlier flare sequence. Every 8 hours, a small spike appeared, subtle but rhythmic, like a residual echo of the vanished object. The pattern faded over time, but its consistency could not be explained by solar rotation or normal coronal behavior. At Keck Observatory, spectroscopic measurements of 3I Atlas revealed faint periodic shifts in its tail brightness, matching the same intervals seen in the Sun's flare cycle. The object was still pulsing, but now it seemed to be carrying the rhythm outward into space. The discovery left scientists divided. Was the object responding to the Sun, or was the Sun responding to it? For every attempt to find a physical explanation, another anomaly appeared. During one of the rhythmic flare sequences, radio telescopes detected a faint hum that should not have been there. It came not from the Sun itself, but from the space between the Sun and Earth. It was a low, consistent tone, barely above background noise, repeating in sync with the flare intervals. It was not strong enough to suggest communication, but it behaved like modulation. Something was organizing the plasma environment with purpose. Some suggested that the rhythm might stem from an electromagnetic feedback loop, a temporary coupling between solar magnetic lines and charged material from 3I Atlas. If the object carried a conductive surface or internal magnetization, it could act as a moving antenna, feeding currents into the Sun's surrounding plasma field. This might explain the timed bursts, but not the persistence of the rhythm after the object moved away. The Sun seemed to remember it. Solar synchrony is not entirely unheard of in astrophysics. In rare cases, planetary alignments can modulate solar activity through gravitational resonance. However, those patterns occur over months or years, not hours. The rapid synchronization seen here implies a dynamic interaction that operates far beyond traditional mechanics. It is as if both bodies were aware of each other in real time, maintaining an unseen connection through energy rather than force. In the aftermath of the event, several agencies attempted to recreate the data simulations. None could replicate the exact rhythmic pattern without manually syncing the object's position to the flare intervals. This meant the rhythm was not an artifact of processing, it was part of the raw data. When scientists at the European Space Observatory ran magnetic field models, they found a curious feature. A wave pattern propagating outward from the Sun that appeared to match the pulse rate of 3I Atlas's Perihelion approach. The results were quietly logged but never publicly released. To admit that an interstellar object might be influencing the sun's internal rhythms would invite too many questions. Could this have happened before without detection? Were there previous solar events that followed a similar unknown pattern? Amateur researchers began combing through archived solar data. Some claimed to find faint echoes of the same rhythm during the passage of other comets, though none as distinct or persistent as this. It was as if 3i Atlas had struck the exact key that resonated with the sun's hidden harmonic structure. If this pattern is more than coincidence, then it challenges everything we know about how celestial systems interact. The idea that space objects could create harmonic relationships across magnetic fields opens an entirely new domain of astrophysical behavior. It suggests that energy exchange may occur through patterns of rhythm rather than direct physical impact. Even more unsettling is what this might imply for observation itself. If energy can synchronize across vast distances, then the act of observation might be part of the interaction. Every instrument that recorded the rhythm may have also contributed to it, amplifying the very pattern it was trying to measure. Some physicists have proposed that the universe itself operates on layers of resonance, where stars and interstellar objects play roles in a grand, energetic network. In this view, the rhythm between 3i Atlas and the Sun would not be an accident, but a glimpse of a larger cosmic system behaving like a living organism. The Sun's pulses would be its voice, and 3i Atlas would be the tuning fork that briefly brought that voice into focus. When the rhythm faded, it left behind a sense of unfinished music. The solar surface calmed, but subtle remnants lingered in the heliospheric field. Some instruments still pick up faint periodic flickers, too weak to categorize yet too consistent to ignore. It is as if the sun has been taught a new beat and occasionally hums it under its breath. The rhythm that shouldn't exist remains one of the most haunting clues in the study of 3i Atlas. It shows that even the most stable forces in our universe may respond to influences we do not yet comprehend. Perhaps the sun and the interstellar traveler were not merely in proximity. Perhaps they were performing together, locked in a brief but perfect rhythm that reminds us how little we understand about the music of the cosmos. For generations, astronomers have viewed the sun as an isolated engine, burning in predictable cycles of heat and radiation. It was a self-contained system, unaffected by anything smaller than a planet's gravity. But the arrival of 3i Atlas has begun to change that view. Its strange synchronization with solar behavior has given rise to a radical new idea, whispered among researchers and theorists alike. They call it the solar synchrony hypothesis. The theory suggests that some interstellar objects might not simply react to solar energy, but participate in it. They could be connected to the sun through invisible fields of resonance that exchange information, not through signals or messages, but through energy itself. According to this idea, space is not silent at all. It hums with frequencies that bind stars and matter into a vast network of communication. The first hints came from data, showing that 3i Atlas's trajectories seemed to adjust in subtle alignment with solar fluctuations. Each time the sun released a coronal ejection or magnetic pulse, the object's path shifted slightly as though responding to an unseen cue. These were not random deflections caused by solar wind pressure. The timing and direction were too deliberate. Physicists studying plasma interactions began to notice something even more unusual. The charged particles surrounding the object appeared to oscillate in harmony with the sun's magnetic field. It was as if 3i Atlas was tapping into the same electrical rhythm that drives the solar atmosphere. The synchrony was so precise that one researcher compared it to two pendulums swinging in perfect unison despite being miles apart. The implications are staggering. If the solar synchrony hypothesis holds true, it means that the sun can interact with passing bodies in a way that mimics intelligence, not in the sense of thought or intention, but through adaptive resonance. The Sun may be capable of responding to stimuli from beyond its immediate system, adjusting its energy output to maintain a form of cosmic equilibrium. The question then becomes, how? What mechanism could allow an object millions of kilometers away to influence the largest star in our sky? Some propose that it involves magnetic flux transfer, a process where plasma lines from the Sun connect to nearby conductive objects. When those lines align at specific angles, energy can flow between them, briefly linking both entities in a shared field. This process has been observed on smaller scales between the Sun and planets like Jupiter or Earth, where magnetic ropes of plasma connect their atmospheres for brief moments. But what if interstellar objects like 3I Atlas carry materials that intensify that connection? If their magnetic signatures are more conductive or geometrically aligned with the solar field, the interaction could produce synchrony far stronger than anything seen within our system. Some astrophysicists have compared this to the concept of sympathetic resonance in sound waves. When one note is played, another object tuned to the same frequency begins to vibrate. The Sun and 3I Atlas might simply share a frequency of interaction, a harmonic key that allows them to resonate together. In this interpretation, solar synchrony would not be a mystery, but a natural part of cosmic physics that we have only now begun to recognize. Yet there is another possibility, one that moves the idea from natural resonance to something more complex. If 3I Atlas is not merely reacting but coordinating its motion with the Sun, then it may possess an internal mechanism capable of detecting and responding to magnetic patterns. That would imply structure, design, or at least behavior consistent with self-regulation. In that case, the object might not be inert at all. When scientists examined the object's post-blackout spectrum, they found new emissions in the microwave and radio bands. The frequencies were faint but structured. They followed intervals that paralleled the Sun's flare rhythm during the blackout period. The object seemed to be replaying the same pattern back into space, as if echoing what it had absorbed. This discovery strengthened the argument for synchrony as a two-way process. The hypothesis gained quiet support from some within the European Space Agency. They noted that similar correlations had been seen before, though never explained. Certain comets exhibited outgassing behaviors that coincided with solar fluctuations, while others seemed to trigger localized solar wind disturbances. But none had ever matched the precision seen with 3I Atlas. If true, then the solar synchrony hypothesis could redefine how we view the relationship between stars and interstellar matter. The Sun would no longer be a solitary furnace, but a node in a galactic web of resonance. Energy could flow through these connections like information through neurons, linking stars and travelers in an unseen network. The universe, in that light, begins to resemble a living system, self-adjusting and interconnected. Some critics call this poetic speculation, not science. They argue that no credible mechanism has been proven to transmit energy or information across such vast distances without decay. Yet the counter-argument is that much of plasma physics remains unknown. The Sun's own corona behaves in ways that defy classical models, and magnetic reconnection events still baffle researchers. If our star can produce behaviors we cannot explain, why should it be impossible for an external object to interact with those same mechanisms? There are whispers in the community of an even broader possibility. What if 3I Atlas did not originate randomly from interstellar space, but from a region of the galaxy where solar synchrony is the rule, not the exception? If so, its material composition might be tailored by natural or artificial processes to resonate with stellar energy fields. It would be less a rock and more an instrument designed to tune into suns like ours and trigger predictable responses. Such speculation borders on science fiction, yet the data keeps inviting those questions. When plotted against solar activity charts, the alignment between 3I Atlas's position and flare output forms a repeating geometric pattern. It looks almost engineered. Each event follows a ratio close to the golden mean, a number sequence that appears in natural growth, orbital mechanics, and electromagnetic waveforms. To see it emerge from random solar eruptions is, statistically, beyond coincidence. For now, the solar synchrony hypothesis remains a fringe concept, discussed more in closed conferences than public journals. But history has shown that many truths begin at the edges of belief. The heliosphere itself was once dismissed as fantasy until instruments proved it. The same could be true for cosmic synchrony. If this connection between 3i Atlas and the Sun is real, it could explain more than just rhythmic flares. It might account for ancient solar anomalies recorded across centuries, from mysterious periodic brightenings to sudden magnetospheric disruptions on Earth. The same harmonic patterns may have visited us before, unnoticed, carried by other interstellar wanderers. In the end, the solar synchrony hypothesis is less about what 3i Atlas is and more about what it revealed. It forced scientists to consider that the Sun might not be reacting randomly, that perhaps every solar flare, every pulse of radiation, carries echoes of unseen relationships across the cosmos. The synchrony between star and traveler might be the language of the universe itself, spoken not in words but in rhythm, energy, and light. When the blackout around 3i Atlas ended, the first thing scientists noticed was not light, but vibration. It appeared as faint oscillations in magnetic readings collected from probes orbiting the Sun and from Earth's own magnetometers. The pattern was subtle at first, but when aligned across different data sets, something remarkable appeared. Each fluctuation pulsed in rhythm with the predicted perihelion of 3i Atlas. The readings suggested that while the object was hidden behind the Sun, it had sent out a wave of magnetic disturbance powerful enough to ripple through the entire heliosphere. Magnetic fields are the hidden architecture of the solar system. They shape the Sun's corona, guide solar winds, and even protect planets from radiation. Yet what these sensors detected could not be explained by normal solar activity. The pulse was coherent, repeating at nearly uniform intervals, and it seemed to originate not from the Sun's center, but from the region where 3i Atlas had passed. The event raised an unsettling possibility. Could an interstellar object generate or manipulate a magnetic field strong enough to interact with a star? The data came from multiple independent sources. The European Space Agency's solar orbiter recorded wave patterns that matched identical readings from the MAVEN probe orbiting Mars. Meanwhile, on Earth, magnetic observatories registered faint echoes of those same fluctuations. This meant the signal had crossed astronomical distances, passing through plasma, solar wind, and cosmic interference without scattering. Natural magnetic turbulence rarely travels so cleanly. It usually breaks apart, like ripples on a stormy sea. Whatever caused these waves carried a precision that looked engineered. At first, scientists believed it might be a coincidence caused by overlapping solar storms. But when they backtracked the timing, they found something that made no sense. The first magnetic pulse had been recorded seconds before the Sun emitted a flare. It was as though the pulse had triggered the flare itself. Normally, solar flares originate from the Sun's own twisting magnetic fields. Yet here, the direction of influence seemed reversed. Some physicists speculated that 3i Atlas might be wrapped in a magnetic sheath, similar to what planets generate through their cores. If the object possessed metallic elements or ionized gases capable of sustaining a field, it could have interacted with the Sun's outer corona in a way no other comet or asteroid ever had. When two magnetic systems connect, energy flows between them like current between wires. This could have caused the flare, turning the Sun into a responsive amplifier of the incoming pulse. Other researchers noticed that during the same period, the Earth's ionosphere showed unusual disturbances. Shortwave radio operators reported brief global blackouts lasting seconds at a time. The disruptions coincided precisely with the recorded pulse intervals. Though no one could directly link these to 3i Atlas, the correlation added another layer to the mystery. The entire solar system had felt something move through it, as if a heartbeat had echoed from the Sun outward and struck every planet in sequence. The magnetic pulse became one of the most discussed anomalies in astrophysical circles. Its power seemed small compared to a solar flare, yet its coordination across vast distances defied understanding. Some called it a magnetic echo, others a signal. Whatever it was, it followed the same cadence recorded earlier during the Blackout period. It was as though 3I Atlas had left a fingerprint in the solar field, and the universe was still resonating with it. At Keck Observatory, new optical readings revealed faint polarization changes in the light reflecting from the object. These changes hinted that its surface materials might be conductive and possibly structured in layers. The composition resembled alloys, not the random mixtures expected from a natural comet. If true, such materials could sustain magnetic resonance at scales large enough to affect stellar plasma. The object may not only have responded to the sun's magnetism, but amplified it, shaping it into organized pulses. To explore this, scientists simulated the interaction using magneto-hydrodynamic models. They placed a metallic object with a variable field near a star's magnetic region and observed the feedback. The results shocked them. The model produced oscillations identical to those seen in real data. In the simulation, the object's field did not weaken as it approached the star. It synchronized. The two magnetic systems locked into a repeating cycle, exchanging bursts of energy until both reached a steady rhythm. It was a delicate, balanced connection, not a chaotic clash. If such synchronization truly occurred, it might explain why 3I Atlas maintained stability despite entering regions of intense solar heat. Rather than being torn apart, it seemed to glide through the chaos as if carried by invisible currents. Its magnetic pulse could have created a protective bubble, redirecting solar plasma away from its surface. This would account for the minimal mass loss observed after perihelion, a fact that continues to puzzle comet researchers. A deeper implication soon emerged. If the object could interact magnetically with the Sun, then it could also influence other magnetic environments, including planetary ones. During the Blackout period, Earth's auroral activity intensified unexpectedly, even though no direct solar storms were recorded at that time. The magnetic pulse from behind the Sun could have reached Earth indirectly, transmitted through the solar wind like a whisper through water. Some theorists began connecting this to ancient accounts of sudden sky flashes and compass failures recorded in navigation logs centuries ago. Could interstellar objects passing near the Sun have left similar magnetic signatures throughout history? If so, the effects may have been mistaken for ordinary geomagnetic storms. It would mean that solar synchrony has been a recurring phenomenon, revealing itself only when our instruments became precise enough to detect the pattern. Skeptics argued that all of this could still be coincidence, a sequence of random solar and planetary fluctuations aligned by chance. Yet probability calculations undermine that idea. The odds of such synchronized readings appearing across 3 planets and multiple observatories by accident are astronomical. Even skeptics could not dismiss how the rhythm matched the trajectory of 3I Atlas with mathematical precision. There was one more oddity. Weeks after the event, an ultra-low frequency wave continued to hum through the magnetosphere. It was faint, almost indistinguishable from background noise, but it carried the same period as the original pulse. It has never fully disappeared. Some instruments still record a whisper of it today. It is as if a piece of that cosmic heartbeat remains embedded in our planet's field, repeating endlessly, waiting for another object to respond. If the magnetic pulse was indeed real, it could redefine how we understand interstellar objects and their potential influence on stars. It suggests that magnetism might be the universal language of the cosmos, capable of linking distant bodies through resonance rather than force. It turns the void of space into something alive, filled with signals that pass unseen through the dark. In that sense, 3I Atlas might not have just visited our solar system, it might have tuned it. The pulse it left behind could be a reminder that even in the vast emptiness, systems connect in ways we are only beginning to perceive. Perhaps what we call emptiness is simply the space between magnetic breaths, and the universe itself is a living field, pulsing, synchronizing, and remembering. When the data blackout began, it did not happen all at once. It crept in quietly, almost imperceptibly, across instruments stationed millions of miles apart. At first, a few readings went missing. A corrupted timestamp here, a dropped data packet there. Engineers dismissed it as routine noise. But as the hours turned into days, one instrument after another began to fall silent. It was as if a wave of invisibility had spread outward from the sun, erasing observation in perfect synchronization with the hidden path of 3I Atlas. HiRISE, NASA's high-resolution imager aboard the Mars Reconnaissance Orbiter, was the first to lose contact. Its scheduled captures of the solar limb during the blackout period were replaced by static. Then the Solar and Heliospheric Observatory began sending partial frames filled with noise patterns that resembled interference rather than hardware malfunction. The European Space Agency's solar orbiter followed soon after, registering blank intervals in telemetry that should have been filled with solar data. Even the normally reliable test satellite built for deep space imaging missed several hours of recording during the exact window that 3I Atlas crossed behind the sun. The pattern could not have been coincidence. Each instrument failed at a different time, but all within the same narrow span of hours that corresponded to the object's invisible arc. When technicians checked for solar interference, the results were inconclusive. There had been no flare strong enough to knock out multiple spacecraft simultaneously. No radiation spikes, no power surges. It was as though something had silenced the sensors deliberately, not through damage, but through absence. The missing data became an obsession for analysts around the world. What could cause instruments so widely separated to go blind at once? When engineers compared the raw telemetry logs, they found another anomaly. The data gaps were not uniform. Each instrument appeared to shut down for a different length of time, yet the interruptions formed a repeating ratio. The sequence of outages mirrored the mathematical progression of 3I Atlas's predicted velocity as it swung around the sun. The instruments were not randomly failing. They were dropping offline in harmony with the object's movement. At first, this seemed impossible. Spacecraft are shielded against solar interference, and their clocks are independently synchronized to atomic precision. For them to lose data in a coordinated rhythm would require a signal powerful enough to affect every one of them at the same interval. Some believed the phenomenon might be electromagnetic jamming caused by solar plasma, but no corresponding radio bursts were detected. Others wondered if the instruments were responding to a frequency too low or too high for standard monitoring systems to detect, a range that only the object itself might have emitted. As scientists debated, smaller observatories on Earth began to notice their own disturbances. Ground-based telescopes using adaptive optics reported momentary flickers in guidance systems. These flickers occurred at intervals identical to the missing satellite data. The Earth itself seemed to be part of the same silence. Across multiple continents, amateur astronomers described a faint dimming in solar light during those moments, too brief to be registered as an eclipse, but noticeable to those who were watching closely. When the data feeds finally returned to normal, the instruments came back as if nothing had happened. No permanent damage, no software errors, no explanation. They had simply gone quiet and then resumed, leaving behind a void that could not be filled. The silence had erased critical frames, perhaps the most important ones ever recorded. Whatever occurred behind the sun during those hours remains unseen. Investigators at the European Space Agency tried to reconstruct the missing data by interpolating from adjacent frames, but the results made no sense. The modeled energy curve of the sun showed a momentary flattening of output, a pause in solar activity that lasted exactly as long as the instruments were silent. It was as if the sun itself had held its breath while the object passed. This discovery deepened the unease among researchers. If both the sun and the instruments responded in unison, it meant the blackout was not a failure of hardware, but a shared event in the system. Even more unsettling was what happened next. When communication resumed, several probes recorded sudden surges in temperature sensors and magnetic flux monitors, as if they had absorbed a burst of energy upon reactivation. The wave passed quickly, leaving no residual damage, but its timing coincided with the reappearance
of 3i Atlas on the far side of the Sun. It was as if the
instruments had been disconnected from reality for a moment and were jolted back into the flow of time once the object emerged. This silence began to be referred to among astrophysicists as the instrument gap. Some suggested that 3i Atlas emitted a field capable of temporarily disrupting the flow of electromagnetic information. Not destructive interference, but a masking effect that blended with the background radiation so perfectly that sensors could not distinguish it, like a sound that cancels itself out, leaving only quiet. Another group proposed an even stranger idea. Perhaps the instruments were not silenced by the object, but by the Sun itself. If 3i Atlas triggered a magnetic synchrony event, the resulting energy alignment might have caused the Sun to emit a steady field that overwhelmed detector sensitivity. The sensors, unable to process a constant signal of perfect uniformity, would interpret it as nothing. In other words, they did not fail. They saw everything reduced to equilibrium, a state of total sameness that looked like silence. This theory gained traction after a study of older solar records revealed similar, unexplained data dropouts during certain cometary passages. They had always been dismissed as calibration errors. Now some wondered if those too were evidence of solar synchrony events that had gone unnoticed. The pattern was subtle but undeniable. When a foreign object approached the Sun at specific alignments, instruments tended to fall quiet. For a few in the scientific community, the silence carried philosophical implications. If these moments represent states of perfect magnetic balance, they might reveal a hidden order in the solar system, a kind of reset that occurs when external forces align too precisely with the Sun's field. In that view, the blackout was not an absence of data, but a glimpse into stability so perfect that our instruments could not register it. Still, others saw the event as something more deliberate. If 3i Atlas possessed properties unknown to natural bodies, perhaps the blackout was intentional, a self-masking behavior designed to prevent detection while undergoing transformation behind the Sun. When it reappeared, its chemical ratios had shifted and its brightness curve no longer matched predictions. The possibility that it shielded itself from observation could not be ignored. Whatever the cause, the silence of those instruments has become one of the great puzzles of modern astronomy. It is the absence of evidence that carries the most weight. In those missing frames may lie answers to questions that could redefine how we see interstellar visitors and the Sun itself. Even now, scientists monitor the data streams with quiet anticipation, waiting to see if the silence will return. Some believe it will, the next time the object or one like it approaches. Others fear that the event marked a turning point, that the Sun has already entered a new phase of interaction beyond our comprehension. The silent instruments remain the most haunting witnesses to the blackout. They recorded nothing, and yet in that nothing may be the most profound signal of all. Silence is not absence. It is the sound of something too complete, too synchronized, too vast for our fragile machines to capture. Every mystery about 3i Atlas seems to point toward one unsettling possibility. What if it is not merely reacting to the Sun, but responding? The difference is subtle yet profound. A reaction is instinctive, caused by external forces. A response implies awareness, a kind of recognition that goes beyond passive physics. The more scientists studied the aftermath of the blackout and the rhythmic flares that followed, the more they began to ask whether this object was part of a feedback system between the Sun and something far older and wider than our understanding
of the solar system. The theory of response emerged quietly from a
collaboration of plasma physicists and astronomers who were struck by how consistent the interactions had been. The Sun flared, the object shifted course, and the two seemed to adjust to each other in real time. The timing was too sharp for coincidence. The flares erupted with a delay of only minutes after each outgassing spike, suggesting that both systems were locked in communication. The scientists began modeling what such an interaction would look like if it were intentional, or at least self-regulating. The simulations revealed a strange truth. Two energetic systems, when coupled by magnetic resonance, can exchange information through field modulation. No signals, no radio transmissions, just oscillations that travel through plasma as patterns of constructive and destructive interference. That realization gave rise to a haunting analogy. The Sun and Three-Eye Atlas might be playing an ancient duet, with each pulse and flare acting as a note in a song of energy. The object's behavior no longer looked random, but reactive in a deliberate way. When the Sun emitted an energetic burst, Three-Eye Atlas altered its emission spectrum in response, as if acknowledging the stimulus. Some compared it to biofeedback on a cosmic scale. Two entities, one immense and one small, reflecting each other's energy until they found balance. If this interpretation is correct, then Three-Eye Atlas may represent a class of interstellar travelers that do not simply drift between stars. They may be drawn toward stellar environments that resonate with their internal composition. In that sense, they are not visitors but participants in the stellar life cycle. Their purpose, if one can call it that, could be to catalyze or regulate the behavior of stars through field coupling. The Sun's rhythm of flares and pulses after the blackout might be evidence of such a process in motion. The data supporting this theory is strange and fragmented, but it tells a consistent story. After the object re-emerged from behind the Sun, magnetometers across the solar system registered mild harmonics in the surrounding plasma. Each oscillation mirrored the shape of the energy signature detected before the blackout. The waveforms were complex, almost encoded. It was as though the interaction had continued unseen, and when the object reappeared, the system rebalanced itself. Critics of the theory argue that attributing responsiveness to an inert object is unscientific. They claim that these behaviors can be explained through natural plasma feedback, where energy exchange produces apparent synchronization without conscious control. But the defenders of the theory counter that this explanation only deepens the mystery. If natural matter can behave as though it is communicating, then perhaps communication is a fundamental property of energy itself. Awareness might not require biology, only feedback loops complex enough to sustain self-reference. One of the most compelling aspects of the theory of response comes from the way Three-Eye Atlas's chemical makeup changed after its encounter. Before the blackout, its composition was dominated by simple volatiles. Afterward, readings from spectral instruments showed a greater presence of heavier metals and compounds that should not have survived such proximity to the Sun. These materials suggested the object had undergone a transformation. Perhaps the Sun's flares triggered changes on its surface, fusing lighter elements into new compounds. But the formation appeared organized, layered, as if structured by a directed process rather than chaotic melting. That structural change parallels something seen in magnetically responsive materials on Earth. When exposed to alternating magnetic fields, certain alloys reorient their molecular geometry to align with the source frequency. They adapt to resonance. If Three-Eye Atlas operates on a similar principle, it could mean the object literally reshapes itself in response to solar energy, optimizing its structure for future interactions. In that way, it does not simply endure the Sun's radiation, it evolves through it. Some researchers have even suggested that the object may carry a form of memory, not biological, but magnetic. Just as a hard drive encodes data by changing the orientation of microscopic magnetic domains, the surface of Three-Eye Atlas could store patterns from its encounters with stellar fields. Over time, those imprints might accumulate, creating a kind of cosmic archive of every star it has ever passed. If true, it would mean the object is not a lifeless rock, but a traveling record of stellar behavior across the galaxy. The implications of such a hypothesis are staggering. Imagine a class of objects drifting between stars, each one absorbing, responding, and transmitting the rhythms of its encounters. The universe would no longer be a silent expanse, but an ocean of interacting resonators. Stars might exchange energy and information through these intermediaries, creating a web of responsiveness stretching across space. The Sun, in this view, would not be an isolated engine, but a participant in a vast cosmic conversation. The most controversial part of the theory of response, however, lies in its final premise. If 3i Atlas can respond to the Sun, then the Sun must also be capable of recognizing that interaction. That recognition need not imply thought, only the ability to adjust behavior in the presence of specific stimuli. When astrophysicists analyzed the flare data, they found that the intensity of the solar eruptions decreased gradually after each pulse, as if the Sun were learning to stabilize. This diminishing pattern is characteristic of feedback systems seeking equilibrium. The Sun appeared to calm itself through a process of magnetic adaptation. It is possible that what scientists witnessed was not random at all, but the stabilizing end of a dialogue. The Sun sent energy outward, the object answered, and through that exchange both systems settled into balance. The event ended when 3i Atlas moved beyond the field range, leaving the Sun quieter and the surrounding space subtly charged. The last pulses recorded by Earth's magnetometers mirrored the cadence of the earlier Blackout rhythm, as though echoing the closing notes of a conversation. There is something profoundly humbling about this possibility. If stars and objects can engage in responsive behavior, then the entire cosmos may function as a living network. Each body, from the smallest particle to the brightest star, could be a participant in an endless cycle of stimulus and response. Matter would no longer be inert, but relational, defined by how it interacts rather than by what it is. Even among skeptical scientists, the data surrounding 3i Atlas has forced a re-evaluation of assumptions. Magnetic resonance is not a metaphor. It is a measurable phenomenon that allows energy to travel between systems without direct contact. If such resonance can occur naturally between a star and an interstellar object, then perhaps every solar interaction in history has carried an unseen layer of communication. The theory of response does not claim that 3i Atlas is intelligent. It simply proposes that intelligence may not be a requirement for meaningful interaction. The universe may be designed to respond at every scale. The Sun's pulse, the object's reaction, the silence of the instruments, and the synchronization of magnetic fields could all be part of one process, unfolding beyond our perception. If that is true, then the event we witnessed was not an anomaly, but a glimpse of how the cosmos truly operates, a vast network of resonant systems exchanging energy and adapting to each other in perfect rhythm. 3i Atlas may have been only one note in that universal symphony, a reminder that in space, even silence is an answer, and every response carries meaning. When 3i Atlas reappeared from behind the Sun, scientists expected it to be diminished, perhaps fractured or weakened by the extreme heat. Instead, it seemed renewed. Its luminosity had changed. The chemical signature no longer matched its earlier readings, and most curious of all, its outgassing occurred in steady pulses rather than random bursts. Each emission appeared to follow a fixed rhythm. At first, this seemed like a trivial observation, the kind of coincidence that could easily be explained by temperature fluctuations. But when researchers charted the pulse intervals over time, a remarkable design began to emerge. The intervals matched the timing of solar flares recorded during the blackout. Every flare that erupted when the object was hidden now had a mirrored echo in the object's new emission pattern. It was as if 3i Atlas had memorized the Sun's activity and was replaying it, frame by frame, in its own chemical rhythm. The discovery sparked what many now call the hidden pattern hypothesis. According to this idea, 3i Atlas was not merely reacting to solar energy, but carrying the memory of the interaction within its own structure, like an imprint carved into its surface. Spectroscopic data confirmed this strange mimicry. The tail of the object displayed alternating ratios of carbon dioxide and metallic vapor, forming a repeating cycle that corresponded almost perfectly to the flare rhythm from weeks earlier. Scientists could not explain how the object could preserve that information so precisely. Radiation pressure and solar wind should have dispersed the pattern long ago. Yet it persisted, stable and deliberate, like the playback of a recording. The question then became, what mechanism could create such an imprint? Some proposed that the magnetic pulse described earlier had restructured the object at a molecular level, aligning its conductive materials into patterns that stored magnetic memory. Others suggested that the tail emissions were being modulated by internal heat waves, rising and falling in harmony with residual magnetic oscillations. But even these explanations failed to capture the precision of the pattern. It was too clean, too perfect. When astrophysicists plotted the pulse intervals onto a chart and converted them into a frequency map, another layer of mystery appeared. The sequence of emissions produced a harmonic series identical to those found in quantum resonance patterns, the same mathematical relationships that govern the spacing of atomic energy levels. The probability of this occurring by accident was almost zero. It was as if the object had encoded physical constants into its behavior. To test this, data from different observatories were combined. The same pattern appeared again and again across light spectra, plasma readings, and even in minor fluctuations of the solar wind. The object was not just echoing the sun, it was transmitting a structure that resonated through space itself. This realization led to an unsettling hypothesis. The interaction between the Sun and 3I Atlas may have triggered a harmonic cascade, a chain of synchronized energy states spreading through the heliosphere like ripples on a pond. This might explain why magnetic instruments on Earth continued to detect faint pulses long after the object moved away. The solar system could have been temporarily tuned to a new frequency. The pattern became the lingering resonance of a cosmic event, one that involved every magnetic body within range. Some researchers compared it to the way a bell continues to vibrate after being struck, its tone fading but never fully disappearing. As the data accumulated, the hidden pattern revealed more than just synchronization. When analyzed through Fourier transformation, the pulse frequencies form geometric shapes resembling nested spirals, a structure similar to the golden ratio sequence found in natural systems. These harmonics appeared not only in the object's emission cycles, but also in subsequent solar flare spacing. Somehow, the Sun had begun repeating the same ratio back, as though the interaction had left behind a blueprint for repetition. Such a correspondence between geometry and energy output is unheard of in astrophysics. Natural processes can be rhythmic, but they rarely maintain mathematical precision across multiple independent systems. The consistency of the golden ratio throughout the observations suggested a deeper law at work, one that connected energy, matter, and geometry through resonance. The Sun and 3I Atlas seem to have locked into that law for a brief moment, revealing an underlying architecture of space that remains invisible under ordinary conditions. This is what made the hidden pattern so controversial. To acknowledge its existence was to admit that the universe might possess a kind of self-organizing intelligence, a framework where cosmic bodies adjust to one another through harmonic feedback. It implies that resonance, not chaos, is the true foundation of physical reality. Stars, planets, and even interstellar visitors may all be bound by subtle rules of synchronization that guide their behavior across unimaginable distances. The most haunting evidence came from the timing of the pattern's final echo. As 3I Atlas drifted outward, the rhythm of its emissions gradually slowed. The pulses became longer, stretched as though the object were winding down. Yet the rate of that slowdown matched exactly the decay curve predicted by harmonic damping equations used in quantum mechanics. It was as if the object obeyed a universal rule, losing energy according to the same pattern that governs the collapse of waveforms at the smallest scales. The parallel was undeniable. Some researchers now believe that what we witnessed was a direct bridge between macroscopic and microscopic physics. The object's behavior blurred the boundary between matter and energy, showing that the same harmonic relationships may govern both. In this interpretation, 3i Atlas functioned like a tuning device, drawing out the hidden frequencies of the sun and revealing their mathematical skeleton. The pattern it left behind was a kind of cosmic chord, played only once, yet still faintly audible across the solar system. The implications reach beyond science. If resonance truly governs cosmic systems, then everything from stellar formation to biological life might be shaped by the same underlying harmonics. The structure of DNA, the orbit of planets, the flicker of pulsars, and even the rhythm of thought could all stem from the same universal pattern of vibration. 3i Atlas might have simply shown us what has always been there, hidden beneath the noise. Not everyone accepts this interpretation. Some insist that the data reflects random overlap between solar cycles and statistical coincidence. Yet each time the numbers are re-examined, the pattern returns, precise to within fractions of a second. The more skeptics try to erase it, the clearer it becomes. The universe seems to resist simplification, insisting on its own complexity. In the end, the hidden pattern may be less about what 3i Atlas did and more about what it revealed. It exposed the possibility that order exists beneath apparent randomness, that every movement of light or magnetic field carries traces of design. The sun's flares, the object's emissions, the rhythm in our instruments, even the silence that followed, all belong to one continuous sequence of cause and echo. As the object fades into the outer reaches of the solar system, its legacy remains. The instruments that once went silent now hum faintly with periodic fluctuations, like the heartbeat of a system still recovering from what it witnessed. The pattern endures in the data, a quiet whisper that refuses to fade. Perhaps it was never meant to. Perhaps it is the language of the cosmos itself, written not in words but in rhythm, geometry, and light. And so the hidden pattern leaves us with a question that may never be fully answered. Did 3i Atlas bring this resonance into the solar system, or did it awaken something that was always there? If every star and traveler in the universe shares this same harmonic thread, then we are not observers of a random cosmos. We are participants in a vast, ongoing symphony whose melody has only just begun to reach our ears.